Okay, excellent. Thank you. Welcome, everyone. Anyone's here for machine learning? That one will be tomorrow, because this one is substituting that. So, Devops. Devops has been around for almost 10 years, and it grew up alongside CE, CD, that movement. And it's still a thing, because there's a world quality report that's released every year in September. And for 2018, the DevOps thing was actually 2 of the 5 most vital points in that report. So it's still a cool thing. So, of course, Wikipedia has something to say about DevOps, but we can focus on these 2 lines, which is automating the process of software delivery and infrastructure changes. And building, testing, and releasing software can happen rapidly, frequently, and more reliably. So, basically 2 things, automation and speed. That is kind of the main focus on the DevOps movement. How many in here have someone in the company called a DevOps? Quite a few, yes. So I would argue that DevOps is a culture, not only a role. You can have a DevOps culture without actually DevOps, but you cannot really be a DevOps in a culture that isn't DevOps. That's kind of contradictory. So, from a tester's point of view, are there any issues with DevOps? Yes, of course, otherwise I wouldn't ask this question, right? So, there is no clear definition, which we'll see. It's actually derived from developers, so quality testing and that part isn't really part of DevOps as it is. And it's an overbelief in automation. Anything should be and could be automated. So if we look at some of the models, this is one. So you should build, test, package, and release. Excellent. This one would state that you have automated tests after deploy and release. It doesn't really mention testing quality before that. And this is probably one of the most popular models, the ever-looping thing. And you have a verify section, and that is where the main chunk of testing happens. So we would, of course, like to have testing happen everywhere. And thanks to Dan Ashby for the original for this one. And how should we achieve this? Well, we need to understand what the activity is in each stage. And of course, any DevOps organization you might have, or DevOps you might have, they don't have this nice model. They have other ideas, models, and stuff. But we'll start in this one, since it's kind of a common one. And if we look at the create stage, for instance, it states that we code, build, release, and design, which is a major part of what we actually do in our day-to-day work. So there's nothing magic about this. It's just that it's packaged in a different way, and it should go out faster. And we then try to identify initiatives that fits into this. And here we actually, I'm sorry, but you have to talk to your developers and your DevOps and stuff to see what their plans are, what are they doing, how can you fit your activities into their activities. And set up a grid. This is just an example. What I find is important to separate if it's something that is easily automated or not, or if it's a human or what I call sapient activity. So you can actually separate those, and you have a map to match against whatever they have done from the DevOps side. Just a pre-warning, I have quite a few slides. I will flip through them quite quickly, but you will get the slide deck afterwards. So you just repeat this for each of all the activities, and you should be good to go. So this basically is my talk. No. This is just another sample, just to give you an idea that you could actually write or build your own model in a different way so everybody can understand it. That's the most important part, a common understanding of what's happening. And I would like to emphasize that you need to have a plan if something fails. What should you do? Should you go back to the developer's machine? Should you fix it or whatever? But you need to have a fallback plan if something fails on the way. So, some initiatives. Most of these you will recognize, but I would say that these things is more important if you're running in a DevOps culture. And some are on the tester side, some are on the developer side, meaning that these rules will merge more and more. So, I guess you've all seen this. Everyone has a test environment. Some are lucky enough to have another environment for the production code. So, it's really important in this stage to have different environments that you can run your automation, you can verify stuff, and if possible, try to make each environment as production-like as possible in all stages. Add databases and stuff to it, even to the local dev machines if possible. Monitoring is an important part as well. Try to add monitoring to everything that is at least a shared environment. That's really good. And agree with people how you deploy between the different environments. If you have local and you merge the main branch, you might have a 4A principle. You should have always green CI/CD pipelines and stuff like that. And then you have more and more controlled deploys. In our company, we have a lot of third-party dependencies. And we need to mitigate those or build them away, which means that for the live environment, because have them there, we have actually a test environment that corresponds to our test environment, and otherwise we need to mock them. That's the basic way of doing it. So, moving on. Linting. There's a lot of discussion about this. If you haven't heard about it, it's basically running a program that will analyze the code for potential error. We're talking about code quality. And this is a good way to get developers into the quality thinking, because they can actually understand what a good code quality might be. And there's loads of different programs out there. We're using, for example, SonarQube, but there are other ones as well, of course, StyleCop, FXCops, and whatever it's called. And one trap that is commonly stepped into is adding too much rules to start with. Especially if you have old code, they will start breaking and breaking and breaking. It'll take forever and ever to fix it. Just add a small set of rules, verify that it's working, and then add rules as you go. Otherwise, they will kind of bail out of this operation. Unit tests. You see this kind of ties into a bit what Glenn was talking about. Unit test is, of course, paramount and should be run on local and on the test environment. That's minimum. Code coverage. You often hear from some people that you should have as high code coverage as possible because that is good, because then you know that everything's working. If you have a rule saying that you should have 80%, 90%, or even 100% code coverage, you tend to end up with people doing asserts that are kind of not really doing anything just to get the code coverage up. So it's kind of a bad idea, I would say. Try to apply a rule that you say that, okay, we start measuring and we shouldn't deteriorate. The code coverage should not go down. You add new stuff, you fix bugs and whatever, and the code coverage should keep the same or go up. That's a good start. And of course, unit tests should be fast. It shouldn't take forever and ever to do it. So you often see people having tests going one after another, which means that if each of these tests takes 5 minutes, it will take about 50 minutes before you find an error in the third one, and it will take 50 minutes to run the whole thing. So try to parallelize as much as possible. It's a really good idea. The whole thing will take 5 minutes, and you will find any issues within 5 minutes. So that's really nice. And to be able to do this, the old classical setup and tear down your test data is a good way to go. Because then you always know what kind of data your test is starting with. So if you have tests that is kind of depending on previous tests, it tends to fail somewhere and then the whole thing starts failing, which is a bad thing. You can do this by building the test data within the test. You can have virtual machines, containers. There's loads of different ways of solving this, but try to know always where you start your tests, where you are in your data. It's a really good practice. So, the master branch is kind of a paramount part of DevOps movement. You should always branch into master. And if you're alone in the system, it's quite easy. You check out a branch, and then you do deep testing in that one, and you merge it together to master, and everyone's happy. In a real-life situation, you're seldom alone as a developer in the code. You share the code base with other people, and if you do deep testing in your local branch, things might have changed on the way, which means that what you tested is not really valid longer in the main branch. And if you wait with the testing until you merge, you might actually introduce breaking changes because you didn't test it deep enough in your local branch. And doing both usually takes too much time. So the middle of the road approach is preferably doing deep test in your local branch and have some kind of smoke test suites running on merge that you can rely on. Okay, we didn't break anything major, the normal stuff is still working, and then you can have periodical tests running each night or whatever that does a deeper analysis of the main branch. Because, as I said, one of the pivotal things is basically the master should always be deployable, and it should preferably not contain any known errors. So, on test automation. There's a lot of talk about test automation on this conference. I will only add a little thing to that. If your developers are doing the test automation and writing the actual code, they will actually do the code better. Because to be quite honest, it's very, very seldom that things are found while you run your unit tests. But they find stuff on the local machine while developing, regardless if you do TDD or if you code first and test later. But while doing that, the code is actually improving and the test is actually improving as well. So this is bug prevention when developers are writing the code for the test. And if you add tests, if you have a CI monitoring or pipeline monitoring, put them in a quarantine for a while. Let them run separately before you add them, so you verify that these tests are actually working instead of adding flaky tests to the pipeline monitor. So you avoid having red tests in your monitoring that are kind of just flaky tests. So run them for a couple of whiles and then add them to the monitoring. Code review, something popular. We use this a lot, and in my world, code review is like a 4I principle. Either you pair program or you mob program, or you actually do a proper code review. But it's quite easy that people do a pull request, and then someone takes that and check all the changed code lines and say, oh, okay, all the changed code is quite okay, we'll move on. So anything that's code should be checked at the same moment. Any test that belongs to the code, any new tests that are added should be checked. And if possible, make people run the code while they do code review. That's the perfect way of actually noticing that it will run or will not run. And as a tester, join the code review. Even if you don't know how to code, you will probably understand the code as you read it, or you can ask the developers when you sit next to them. It's like learning a new language. It's often very hard to write stuff in that language, but you can often read something and understand from it. And it gives you a better understanding how the developer is thinking, and they will understand how you are thinking while you do your tests. So, canarying or Canary Deploy. Anyone heard of it? I see a few hands. Yes. So this is a really good way to go. Basically, it means that you deploy to a small part of your live environment, and then you verify and notice that it's actually working, and then you add another part, and then another part, and you move on from there. Good tip, try to find out which is the cheapest part of your live environment. Start there. For instance, we have a platform serving around 25 different brands or sites, and that is chopped up into 6 instances. So we'll start with one instance, verify that it's working, monitoring closely, and then we take the next and the next and the next, instead of deploying everything to the whole place and it starts breaking. Then we can move back again fast. So, anyone recognize this? You have an Agile board. Mainly all the columns belong to everyone in the team except for one column that belongs to one role or one person. It's called test or QA or verification or something. And you have everything between 3 to 8 people adding stuff into this, and you have one poor person trying to solve everything that's ended up in a test column. So good practice is actually to add stuff from left to right, but empty the board from right to left. Meaning if you have stuff in the test column or any other ones to the right, don't check out anything new. This means that everyone in the team need to chip in on this column as well. So coaching, reviewing, actually enhancing the knowledge of how to test, how to verify is kind of built into the system. And pair testing or mob testing, it's actually a good way to move forward. You pair up with someone, or you sit in the front of a big monitor and do stuff, and you learn at the same time. This is especially good for exploratory testing, of course. And quite honestly, everyone likes this pairing thing or mobbing thing. It's kind of funny, but get a really big monitor, so you don't want to have to use binoculars to see it. No, but it's a good movement. Don't do it every day, but every now and again where it fits. And this is one of my babies. Definition of ready, definition of done, getting increasingly more important when you're doing a DevOps, when it needs to go run fast. You need to know that the item is actually ready to be put into the sprint or on the board, and you need to know when it's done. Otherwise, you have some kind of limbo state that 80% of the stories are 80% done, and you don't really know what is needed to fix the last part. So set the definition of done for the story and follow that one. And then you know that you can move on. So back to monitoring. As I said, the state of the build should be everyone's primary interest. I come back to this often, that this is actually the team's responsibility to make working code. And it should always be green. It's very, very easy to have this broken window syndrome, which means that, oh, we have actually, that one was red for 3 builds, but it's just a small thing, it doesn't really matter. So if it's a small thing, fix it or remove it from the monitoring. It's easy, because the more red stuff you have, the more you start ignoring this. And as it goes faster and faster, you have faster iteration, smaller iteration. It's really important to have this working. And have a dedicated monitor central in the team. Otherwise, it's be like one person's problem. They check the monitoring, and they call the team saying, hey, it doesn't work. This should be obvious for everyone. And make sure that everyone understands that when everything's green, doesn't mean there's no defects. It just means that we didn't find any defects. It's not the same thing. And system monitoring. Monitoring is kind of cheap and easy, so it's kind of easy just to add stuff, loads of stuff to the monitor. And you get a very clogged dashboard. Try to make it very, very streamlined and neat, and then be able to drill down into the monitoring and see what's breaking. And try to use the same monitor for different environments. So if you have a monitoring for a production environment, do the same for whatever you have, staging, build, integration, whatever they're called. It's really good. And share useful information or monitoring. Because if you have other teams that might be interested in what your system is doing, how it feels, it's a good thing to share your monitoring or have a central dashboard. It might be that you have a central support organization or a so-called NOC, and they could be interested in this as well. So, a bit of controversy, monitoring versus testing. When you talk to people that work actively with testing, they kind of realize that we are monitoring partly the same thing that we are actually testing. So can't we replace the testing with monitoring? Because they're a lot quicker. Testing is kind of expensive. Monitoring is cheap, as long as you have the tool in place. And yeah, maybe. The thing is that if you don't test, if you don't exercise the code in your systems before it actually hits production, it means that it's not until it hits production that you start find stuff, and that's where your monitoring is. So yeah, you will introduce more things to the production environment. And that might be okay if you actually have A/B testing, Canary Deploys, or something that mitigates the impact. You could also have the Amazon green and red system, where you deploy to one system, you switch that on and switch it back again if it doesn't work. You have a support and tech organization available that can act quickly. If something breaks, they will act really fast and fix that. Or you have extremely loyal users. This is seldom the case for one and only organization, so I wouldn't say that you should use monitoring instead of testing. Use it to complement the testing. Monitor your systems, your servers, stuff that you don't really usually test normally. So prioritize and implement. That's this third and last step. We introduced a system called Tequila for bringing it all together. It actually doesn't mean anything. It was just a name that stuck, and you find it in the intranet wherever you look for it. So we don't have much drinks in our intranet, so It's easy to think. It's based on something called the Google Test Certified. Google built this model to make developers more into the testing part. So we kind of took that model and made it our own. And this is something I would really like to emphasize, that whatever model you're using, make it your own. Don't just try to blueprint everything. I know that a lot of people are, oh, we have these tribes and whatever from Spotify, let's use that. You need to actually make the model your own, whatever model you use. So we sorted out all the internal dependencies to fit into a 5-stage model, what needs to be done first and secondly and so on. And this is what we came up with. This is like the version 5 or 6 or whatever. So we know what to do. We need to fulfill that one, and then we move on to the next one. If the team is ready, they can take one of the other directions if they want to. But at least we have a really good plan. We have cut it down to small pieces that are really easy to work with, which is a lot better than just having a big bucket of initiatives. To implement this, we did the following. Each team had a representative. So I'm a QA manager for 12 teams. We have around 60 to 70 developers. We have 2 QAs. So we kind of had to do this to move on. So it could be any team member. It doesn't have to be a QA or tester that sits in this board that sets up the workshop and identify what to do, how to implement it. And then we'll repeat the same thing in the team. And the team needs to be on board. So if the team isn't on board, try to find some advocate or ambassador in the team and start with them and introduce the stuff. And as time goes, hopefully we have this nifty little thing that is often used when it comes to DevOps. But I would say that this works within the DevOps culture. That is not DevOps. It's like something that evolves within the DevOps culture. And there's usually something magic happening there, and that's cross-section, which is really cool. And I know that some people claim that it's too magic, it won't happen, but I have actually seen it happen, and it can, which is really, really nice. So, anyone who disagrees, raise your hand. It's a bad plan if it admits no changes. We have tried out a lot of stuff going here. We have tried and failed. You need to do that. But you also need to kill your darlings. I mean, if you have something that you think, this is a really good idea, and you see it's not working, just leave it and move on. You can't just nurture your ideas because you thought it was a good idea to start with. And that's it. That's for me.
Thank you, but we still have time for questions.
Okay, cool.
So, thank you.
Hey.
Hey.
Thanks for the nice presentation. I mean, in the Google certified test, the diagram that you showed, where do you have the window for system testing or end-to-end testing?
That goes within different initiatives. So we don't focus that much on the unit end-to-end system and so on. This is on a high level. But that's also one thing. And actually the end-to-end test is our biggest challenge currently. Because we have 2 geographical locations, we have 12 teams, we only building the platform. Then we have another like 10, 15 teams building the sites. So we're still arguing who's doing what when it comes to end testing. And this is just building our platform to be able to do this more cool, nifty stuff on top of it. So this is just a start. We'll probably build an equally looking model for the next step. But each team is actually doing like end-to-end for their part, but we haven't got any overall end-to-end system. We're aware of it, but it's not in this model.
Thank you.
Hello, my name is Alexei. I have a question. So you told me that you saw that magic happened.
Yes.
Can you tell me the name of company? Where have you seen it? Because based on my experience, I have never seen that before, unfortunately.
We have managed, and mainly due to this model, since we used to have testers in QA in each team, And we went the other way. We tried to make all the testers and QAs develop more, getting more technical, which in the end meant that we lost some that wasn't really into the technical stuff, and the other ones transformed into developers. And they didn't want to be the QA or tester within the team anymore, so they kind of stayed at developing. I don't do any testing anymore, which meant that we still have to have the team catering for their quality, for their stuff.
Person is universal.
Yeah, not totally. We have something called a knowledge matrix and a personality matrix, which we kind of shift into things. So we have the person, a lot of traits that we want them to have. They need to know .NET, whatever, which I kind of push them in there and say, okay, we need to have at least 2 person that knows this, 3 person that knows that per team. And if we are lacking some knowledge within the team, it could be testing, exploratory, .NET, whatever, we kind of get that resource in the team or we train them for that.
Okay, how long it took to build such team?
The first one, between 6 months and a year. So it's nothing that happens overnight. Nope.
Hello.
Hi.
I really liked the part you mentioned about taking models from other companies and personalizing it. Yeah. In our company, we have run into similar problems when trying to adapt from different companies. When you were presenting to your superiors about taking some models from other companies and personalizing it, was there a lot of setback, or were you able to sell the idea that we have to tweak it to suit our company and our staff?
No, not really, because we ran this, so to say, under the radar for a while. So we ran it dry under the radar a bit, trying to see how it worked for us. And then when we actually realized we needed the buy-in from management as well, we did a presentation on it, and we didn't say straight out that we tweaked it a lot, but I mean, this is a model that comes from Google that kind of opened doors directly. And we adapted it to our situation, how we want to work, and we actually have tried it out a bit. And we didn't have any problems really with management getting time for it. Of course, there's always new features, new business ideas, stuff like that comes in the way for this. But we have something called the OM group that decides on the initiatives we're working on. And we actually got our own line in their Excel sheet that they use for just quality initiatives. And we decide what goes into that quality initiatives. But we really had to sell it, yes. Okay, that's it?
Yes, indeed.
Okay, see ya.
Okay, last question.
I have one question. How should a tester review the code written by a developer when they are working on a different release? Because it happens that the developer release and we need to test, and then we kind of are a bit late.
We have worked our way out of that situation, basically. So we are all teams are working on the same stuff. It might be a couple of different features, but we are all on the same stage, so to say. Which means that in the definition of ready, we have already set up how should this be tested. Should we automate it, yes or no? Do we have some kind of test cases, yes or no? And we move in that direction. So it's very seldom that the developers do their stuff and then the testers do their stuff. It's kind of intervened. And I would say that's the only way to make this work really properly. Because otherwise you as a tester will come in at the end anyway and do stuff that is kind of already set. And if you find stuff, they will kind of have to reopen the code and restart and stuff. This is an ongoing process. So usually some teams have a column for testing, and some teams are actually using tasks for testing just to get in more appropriately on the way. So we kind of worked our way out of that situation because that, doesn't really work for us.
Thank you. And this was the final question.
Okay, thank you. Thank you.